We're going to look at solving exponential equations where we have to switch them to a common base. Okay? So that means that I want the base here to be the same as the base here, right? So the first thing that I want to do is I want to think in terms of 6. So I'm going to see if I can write 216 as a power of 6. So if I think 6 to the first, that's 6. 6 squared, that's 36. If we do 6 to the third power, that is indeed 216. So what I can do is I can rewrite this right side as 6 to the third. So 6 to the negative 3r minus 2 equals 6 to the third. Well, notice that our bases are exactly the same, so that means that we want our exponents to be matching in order for these to be equal. So what I can do is I can drop the bases, since those are already equal to each other, and I can set the negative 3r minus 2 equal to the 3. And then we can just solve this linear equation like we've always done. So we're going to add 2. So then we get negative 3r equals 5. And then we divide by our negative 3. So then our r is negative 5/3. So if we plug in negative 5/3 into our exponent, then we would end up with getting 6 to the third, which is 216. Okay. Now, if we look at this next one, notice here that I need to combine these first, right? We have both of these are the same bases, right? So I can combine those. Remember, when you have the same bases and you're multiplying, you're going to add the exponents. So this will turn into 5 to the 1 minus 2m plus negative 3m equals 5 to the 3m. Okay. So if I simplify, we've got the negative 2m and the negative 3m that are like terms. So we have 5 to the 1 minus 5m equals 5 to the 3m. Again, we have where the bases are the same. This time we didn't have to change anything on the bases, so that's great. But now we want to have our exponents be equal. So I'm going to set the exponents equal to each other. So I'm going to come up here, 1 minus 5m equals 3m. Right? So if the exponents are equal, then we know that the whole thing will be equal. So here we're going to, there's a couple ways that you could go about it. You could add the 1, then subtract 3m. It's fastest it's not what I wanted to write. It's fastest if you just add the 5m and get the m's together. So you could also subtract 3m. That's an acceptable way to go about it as well. So then we get 8m equals 1. So then we're going to divide by 8. So then we get m is 1/8. If we look at our next example, notice that we've got, this is a 1/6 and this is a 36. So when I've got a fraction, I'm going to look at the bottom to see what base it can go with. So here, I'm looking at the 6 and then 36. So I'm going to take the smaller of the two numbers, so the 6 in this case. I'm going to see if I can write 36 as some power of 6, which notice we already did the powers of 6 up here, so 6 squared is 36. So I'm going to rewrite this to be 6 to the second, but that's still raised to the 2n, right? And that equals 1/6 to the 3n plus 2. Well, we have a problem because this is a fraction and this one is not, right? So we're close on the bases. Hopefully you remember this property that we have. If we have a to the negative n, that's really the same thing as 1 over a to the n. So that means that this I could really write as 6 to the negative 1. So I'm going to rewrite this right side as 6 to the negative 1, but that's still being raised to the 3n plus 2. So now we have a power raised to a power. Remember, when you have a power raised to a power, that you multiply the two exponents. So we're going to do that on both sides. So that gives us 6 to the 2 times 2n, so 4n, equals negative 1 times 3n plus 2. Do not forget to distribute the negative. So that gives us 6 to the negative 3n minus 2. Again, our bases are matching, so that means we want the exponents to match. So we have 4n equals negative 3n minus 2. So I'm going to add the 3n to the other side. So then we get 7n equals negative 2. And then I'm going to divide by 7. So n is negative 2/7. Okay. If we look at this next example, notice here that we've got a 64 and a 16. So if I take 16, if we look at our powers of 16, we're going to do 16 to the first is 16, and then if we do 16 squared, that's 256, which is obviously not 64. So what happens is that then we have to think about a smaller number that maybe both of these could have a base with an exponent to. So if I think of 16, I know that I can write 16 as 4 squared. We could also write it as 2 to the 4th is 16 as well. So then I want to make sure that I can get 64 either as a base of 4 or as a base of 2. Okay, so if we do, if we try 4 cubed, that gives us 64. If we try 2 to the 6th, that also gives us 64. So we have two options here that we could use. We could write it as powers of 2s or powers of 4. I'm going to choose powers of 4 because that's the one that I saw first between these two. So now you can either start by combining the 64s and then taking it to rewriting it as a power of 4, or you can write each one as a power of 4 and then combine. You'll get to the same spot eventually. So I'm going to do 64 to the 1 plus m plus 3, right, because this was to the first power. And when you're multiplying, you add the exponent. So we have 64 to the m plus 4 equals 1 over 16. So now I'm going to rewrite both of them as powers of 4. So our 64 was really 4 cubed, but that's still being raised to the m plus 4. And our 16 is really 4 squared. Right, so then I'm going to erase my thinking over here. So I have a little bit more space. But notice, again, we've got this is in the bottom, which I don't want in the bottom, so I can move it to the top and change it to a negative. So we have 4 cubed still raised to the m plus 4 equals 4 to the negative 2. Or you can write it as 4 to the 2nd to the negative 1, which gives you negative 2, either way you want to think about it. So here on the left, we've got a power raised to power, so that means I need to multiply these two things, and make sure you're multiplying and distributing that. So we have 4 to the 3 times m, which is 3m, and then 3 times 4, which is 12, equals 4 to the negative 2. Right? So now we finally have where our bases are the same, so then we want to set our exponents equal to each other. So then we can have 3m plus 12 equals negative 2. So we can subtract our 12. So we get 3m equals negative 14. And then we can divide by the 3. So m is negative 14 thirds. Right, and that's how you can change using common bases.